we're going to try to solve problem 43, but 43 refers back to 42. So let's read 42. It says, Justin wants to fence 3 sides of a rectangular exercise yard for his dog. So the 4th side of the yard will be the side of the house. Now he has 80 feet available, but that's in 42. What we have is 60 feet available. So find the dimensions of the exercise yard that will maximize the area. Let's start here. Let's draw the side of a house. All right, so maybe this will be the house here. And then out here, we're going to have an exercise yard for his dog. Now what we want to do is we want to maximize the area. All right, so when I see problems like this that say maximize the area or minimize the profit, maximize or minimize something, I'm going to write what it is I want to do. I want to maximize area. Now, I look around at what I'm given up here, and I'm given no function. So what that tells me is this: get an area function. So let's look at what we've got. I need to get an area function. And what are we dealing with? We're dealing with a rectangle. And I know the area of a rectangle, right? The area of a rectangle, I'll write it here, is length times width. So let's look and see what we have here. We have, say I call that a width. I've got 2 widths, this one, and only 1 length, right? Because we don't need a fence on this side. So I really just need this, this, and this. All right, so if I start here, if I call this x, this would also be x. Now, then the question is, what is that length right there? Well, how about this? Does this make sense here? How much fencing do we have altogether? We've got 60 feet. So if I've got 60 feet altogether, and then I use up x here and x here, how much have I got left? Like, for example, I've got 60 feet altogether. What if I used 10 feet on that side, 10 feet on this side? How much would I have left? Well, I'd have the 60 minus that 10 minus that 10. But we don't know that it's 10. So I think what we're going to have here is we're going to have this is equal to the 60 feet minus an x minus that other x, or how about 60 minus 2x? All right, so now I think we're in good shape. So what is that area? The area of that rectangle is the length, which is 60 minus 2x times the width, which is x. Right, see what I've done? The length is 60 minus 2x, that's the length, times w, the width, right there. So let's multiply through. So we're going to get that this area of that rectangle is 60x minus 2x squared. Now I'm going to rewrite that to look like this. The area of that rectangle is negative 2x squared plus 60x. Now, can you see what A, B, and C are here? A is the coefficient of the squared term. That's a negative 2. B is the coefficient of the linear term, which in our case is 60. And C, well, that's a 0, right? Because there's really a 0 out here. There's no constant. Now, look at this function. This function here is a quadratic, right? It's quadratic, and the leading coefficient is negative 2. So this is a quadratic that if we were to draw, would look like this. I'll do it up at the top here. It's a quadratic. It's a parabola that opens downward. So we do have a maximum value right here. And that's going to occur right there. So we need to know the vertex. And then we'll have both things that we need. So what's the vertex for this function? Well, we know that the x component is negative b over 2a, and then something for y, which we'll get. So the vertex, all right, let's get this b over 2a. So what is negative b over 2a? So this is negative b, and b is 60, over 2 times, well, 2 times what? Negative 2. All right, so we'll get negative 60 over negative 4, so that turns out to be 15. So what do we have? So what is this? This is the x-coordinate. Now the x-coordinate is what? Follow it back over here. That was the width. All right, that was the width. What do we get for the length then? All right, so that 15, let's just say what it is here. That 15, the width is 15 feet. And what is the length? Well, the length, right, we have the length right here. It's 60 minus 2 of those widths. So this is going to be 60 minus 2 of those 15s. So 60 minus 30, which turns out to be 30. All right, so to maximize the area, we're going to have a length of 30 feet, a width of 15 feet, and then why not? While we're here, let's just go back. We know what x is, right? If we go back here, what did we get for the x value of our vertex? We got 15. So if we go back in here into our function and put 15, we should be able to get the actual area. Not that we're not asked for it here, but why not? So let's get that area. So we're going to get 60 times 15 squared. No, just times 15, right? Minus 2 times, there's the 15 squared. So my calculator says that the maximum area then is 450 square feet.